Today we're going to talk about tree diagrams. And tree diagrams are fantastic because they allow us to really easily determine and figure out in a nice systematic, organized, graphic, visual way what the chances of things happening is going to be. So when we create our tree diagrams, it is important that we create our tree diagrams with a little bit of a chart. So what I've already put on the page here for you is, obviously based on our situation, which we'll come back to in a second, we're going to have flip number one. That's going to lead us to flip number two. And then what we can determine are the possible outcomes depending on those flips. So let's talk about what our first example is today. So what we have here is a situation where we're going to flip a coin twice, and we want to know how many possible outcomes there are. So keywords here are, we're going to flip a coin, which means that we only have one coin that we have to deal with. And because we are dealing with a coin, like we talked about earlier in the week, we know that our options are going to be heads or tails. So for flip number one, it doesn't matter what I do. I know that when I flip my coin, it's either going to land on heads or it's going to land on tails. So those are my two possibilities for flip number one. Depending on what it lands on for flip number one, and I'm just going to draw some little lines to show this out. For flip number two, I can land on heads or tails. And if I flip a tail first, for flip number two, again, I can land on heads or tails. So when I come with to determine my possible outcomes, if I think of adding together flip one and flip two, my first option is to have flips that are heads, because I can flip a head in flip number one and head in flip number two. A second possibility is heads, tails. And that's going to be if I flip a heads for my first flip. If I'm flipping tails first, my possibilities are going to be tails, then heads. And then finally, my last possibility is going to be tails and then tails. So one thing I want to identify, and this is just going to help make my life easier later, is the fact that I have 4 total possibilities or possible outcomes, because I can have heads, 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 tails, tails, heads, or tails, tails. Now, depending on what my question asks me to go looking for, I can determine what exactly the probability or the possibility of each thing happening is. So let's take a look further down the page to make sure that we can figure that stuff out. So for question A, it says, what is the probability of landing on different sides? So by landing on different sides, and I'm just going to use a red pen here to identify that, that means that I get one side with flip number one and a different side with flip number two. So I can just look through my possible outcomes because I've taken some time to organize them, and that can happen in this particular situation here because I can get heads and tails, or it can happen in this particular situation here because I can get tails and then heads. So to answer the probability of landing on different sides, I can take 2 out of 4 because I have 2 positive outcomes divided by my 4 possibilities or possible outcomes. I can turn that into a decimal, which is going to be 0.5, or I can say that I have a 50% chance of that happening. For example, or question number B, what is the probability of landing on the same side? So in this particular case, I want to think about, and I'm just going to draw a little line, I want to get the same on flip one as I do on flip two. So again, I can look down my possible outcomes and see that heads, heads, that's going to give me the same on both flips, or tails, tails, that's going to give me the same on both flips. So again, I have 2 positives out of 4 possible outcomes, which is going to give me a decimal of 0.5, which is going to give me 50%. Now the last question that I'm looking at is, what is the probability of landing on at least one tail? So what I want to do is look down my chart of possible outcomes, and in this particular case, just to make my life easy, every time I see that a tail has turned up, I'm going to circle it. So I've got a tail there, I've got a tail there, and I've got 2 tails in that particular case. So because on this combination of flips, that happens in 1, 2, 3 situations, the probability of landing on at least one tail, because that's the key part of my question there, is going to be 3 out of 4 possible outcomes, which is going to give me a decimal of 0.75, which is going to give me a probability of 75%. So when we're using tree diagrams, we need to ensure that we show a couple things, all right? We need to make sure that we show trial number 1, and in this particular case above, what we had was flip number 1. We need to make sure that we show trial number 2. In this particular case, we showed flip number 2. There may be situations down the road where you have to show further trials. So you might have to flip your coin a 3rd time, for example. So you'd have to make sure that you show that. You finally, once that is all done, need to make sure that you show your possible outcomes as a nice organized little chart, and that's what we did up here to show in our nice organized little chart. And the final thing that we want to do once we've showed our possible outcomes is identify the number of possible outcomes that we have in total, because that's going to be the denominator once we start calculating our probabilities. All right, in example number 2, what we have is a spinner. So instead of using dice or cards, we're going to use a spinner this time. Now, the key thing that I have to make sure about my spinner is that each of my spinner sections are split up into equal sections. So you can see here that my spinner is split up into blue, green, and red sections, and that each of those sections represents 1/3 of my spinner. If one of those sections was a different size, that is actually going to change the probability of me landing on a specific color. So in this particular case, it's nice and straightforward because everything is the same size. I've already taken a second to set up my column. So on spin number 1, I'm going to land on a specific color. On spin number 2, I'm going to land on a specific color, and then I can figure out my probable outcomes or possible outcomes. So in this example, what I want to do is list all the possible outcomes if I have 2 spins. So if I spin the very first time, there are different options, or 3 different options that I can land on. I can land on the blue section, I can land on the green section, or I can land on the red section. And I have an equal opportunity or an equal chance of landing on each of those sections. For spin number 2, and again, I just have to think of resetting this. So if I land on blue the first time, and I'm going to just draw some lines, I can land on, for spin number 2, blue, green, or red. If I landed on green the first time, I can land on blue, green, or red for my second spin. And if I landed on red the first time, I can again land on blue, green, and red. Now I've chosen just to put everything in the exact same order. That just works for me. You can change that around, but if you'd like to stay nice and neat and organized, that's probably a good suggestion. So if I land on blue in my first spin and blue in my second spin, I can say that the possible outcome for one of my possible outcomes is to land on blue, blue. If I land on blue and then in my second spin green, I can land on blue, green. And if I land on blue on my first spin and red, I can land on blue, red. Now, I just like to put a little line underneath each of these sets just so I can keep them a little bit more organized. And again, that's just for me. So my next options, I can have green, blue, green, green, or green, red. And my final set of possible outcomes, I can have red, blue, red, green, or red, red. Now, before I start answering my questions, I do want to make sure that I calculate and figure out and count how many possible outcomes I have in total, so I can just count that down. And I'm going to have 9 possible outcomes in total. So that's going to be the denominator that I use in all of my calculations. So when I scroll down the page, I can take a look at part B, which says, what is the probability of getting the same color? So what we're talking about here is getting the same color twice. So when I look at my possible outcomes, what I want to look for is basically the same letters beside each other in my possible outcomes. So I have that happening there, I have that happening there, and I have that happening there. So the number of possible outcomes that I have of getting the same color in 2 spins is going to be 3 out of 9, which when I turn into a decimal and round to 3 decimal places is going to be 0.333, which is going to give me a percentage of 33.3%. When I take a look at part C, where it says, what is the probability of getting different colors? What I have to look for are letters in my possible outcomes column that are different. So I've got that one, that one, that one, that one, that one, that one. So when I count up my orange ticks or my orange lines, I can see that I have 6 out of 9, which are going to get me different colors. which is going to be a decimal rounded of 0.667, which is going to give me 66.7%. So the final question that we have down on the bottom of our page asks, is this game fair? So in order for a game to be fair, the probability of one person winning versus another person winning does need to be 50-50, or 50% for me and 50% for you. So in this particular case, because if, let's say, I chose to go, if I landed on different colors, I win, and you said, oh, if I land on the same colors, I win, because these numbers are not equal or equivalent, that means that this particular game is not fair. So in order to get a game that is fair, you have to have it split 50-50. And that's what makes it fair. Or in this particular case, maybe 25-25-25-25, or 33-33-33, right? But the percentages do have to be the same if the game is considered fair. So in this particular case, this game is not fair because if this is what I chose to win by, right, I'm going to win twice as much as you are.